Let's start that. There we go. Check.
The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and nobody else at this point, welcome to this. Sorry. Excuse me for one moment. Audio glitch there. We're back. On behalf of RBCS, welcome to this webinar on myths of exploratory testing. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I'm the author of 12 books on software testing, including the bestseller Managing the Testing Process and 4 books on the ISTQB program. Attendance at today's webinar earns PMI PDUs. I would like to thank Rex Price for reviewing the materials for PDU status and making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. PDUs are available for live webinar attendance only. Before we start the presentation, a couple of housekeeping notes. If you have any questions, feel free to submit them at any time throughout the presentation via your webinar interface, but please note that I will be answering them only at the end of the presentation. There's no need to ask for copies of the presentation. It is already on our website. Go to rbcs-us.com. From there, select the Resources tab in the upper middle of the website, upper middle of the homepage, and then navigate to the basic library. By attending this webinar, you have been automatically registered for the free e-learning drawing. Check your email over the next couple days and watch that spam filter. Hope you enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS, we are a not just for profit company. So today, we'll be talking about some of the myths of exploratory testing and how exploratory testing can be used, how it is sometimes misused, where it came from, and where people sometimes think it came from. So first off, when I say exploratory testing, what might I mean by that? So what I'm talking about here is a testing technique where the person doing the testing is going to use their knowledge, their experience, and their skills, which might include skills related to the software itself, the domain in which the software is used, the building of software, and formalized testing design skills such as state transition diagrams, decision tables, pairwise testing, and so forth. And as the exploratory tester does the exploratory testing, they are testing in a nonlinear and investigatory fashion. Now, what I mean by nonlinear and investigatory is that, well, an example of linear way of testing software would be that I would be following a checklist or following a pre-written script, and I would not deviate from that. Nonlinear meaning there is not a predefined set of steps, and investigatory meaning that as I discover new information through the running of the test, that is going to change what I do subsequently, that I'm constantly informed by the results of the test to modify the test in real time. So that's what when I say exploratory testing for the remainder of this presentation, that's what I mean. So some questions to look at. Origins, where did it come from? Is it magic quality pixie dust that when applied to an application can allow you to test it fully such that you have confidence in the product within an hour? Is it that kind of thing? Um, is it the one true way of testing? Or is it just an unmanageable, unaccountable random bug hunt? Um, is it possible to test without it? There are a number of myths um, out there in the testing world about exploratory testing in these areas, and this is my attempt to dispel some of those myths. Um, Now, a couple terms here on this slide that are worth explaining: the test basis and the test oracle. If you're not familiar with those, by test basis, what I mean is what my tests are derived from. And by test oracle, I mean the thing I refer to determine whether the test has passed or failed. So if you think about a classic requirements-based analytical testing strategy, what I'm going to do is I'm going to sit down with the requirement specification, and I'm going to analyze that requirement specification and create a set of test conditions that I want to cover. And then I'm going to design tests to address those test conditions, specific tests. And when I go to define the expected results of the test, I'm going to refer back to the requirements as the source of those expected results. So the requirement specification is the primary test basis and the primary test oracle. Now notice I'm using the word primary here. There can be, and generally are, secondary test bases and test oracles. So for example, there might be a reference system that you're looking at, competitor system or a legacy version of your system, that you say, well, our new system is supposed to work like this reference system, so that's one of my test oracles. I'm going to refer to how it behaves as part of defining how my system should behave. And in exploratory testing, I certainly can use documents like a requirement specification, excuse me, reference systems, those sort of things as secondary test bases and test oracles, but primarily what I'm basing my tests on and what I'm making the pass-fail decision on is my skills, experience, and knowledge, as I mentioned previously. Now, any form of testing that is focused on skills, knowledge, and experience as the primary test basis and as the primary test oracle is experience-based. So, for example, if I create in advance a checklist of problems that I have seen in the past with our system, or things that I have read in users' reviews of our application, and I use those as checklists to do my testing, then that would be an experience-based form of testing, because it is the checklists were derived from experience. But notice that is a linear approach to testing. So what's unique about exploratory testing as a form of experience-based testing is that non-linearity and, as I said, the investigatory nature of it. That's going to make it different than following a checklist that has grown over the years via experience. Now, the ISTQB did a survey of testing teams around the world, and what we found in that survey was, and you can download that survey from the ISTQB website, that 2/3 of test teams report using exploratory testing. So it is a very, very commonly used technique. The only technique that is more commonly used is use cases, which is a 70% rather than 66%. So, virtual dead heat there. Now, one of the things, if you do download that survey and take a look at it, one of the things that I would encourage you to keep in mind is that the low penetration rate of more formalized um, test design techniques that you see in that survey, I think has a lot more to do with lack of proper training of testers. And testers perhaps getting a foundation certificate and having basic exposure to some informal test design techniques, but then not actually knowing how to apply those techniques when they get back to work, which is a problem that can happen if people self-study or if they use just some of these sort of brain cram courses that's just trying to teach them the exam. The basic takeaway, though, of this figure, and the reason that I bring it up, is there's certainly a lot of testing being done out there using exploratory testing. I mean, if you do the math, there's going to be millions of person hours of testing done every year, and so a substantial proportion of those person hours of testing are going to be done doing exploratory testing. So it is important that this be done right, as it is a very I wouldn't say dominant technique, but a very widespread technique, nearly ubiquitous technique. Now, another thing that's worth mentioning about exploratory testing is that exploratory testing is validation, because what we are doing is we are checking to see whether the software actually solves the user and customer problem and will meet their expectations. Now, of course, again, keep in mind that the tester's skills, experience, and knowledge are the primary test oracle here. So it's the tester is acting as a surrogate stakeholder here, a surrogate user, a surrogate customer. They're validating against their own expectations and standards of quality and so forth, which can be a problem. I remember in one circumstance where I was managing a team and we were testing a device that was designed to be used by people who'd never used computers before. I had to keep telling my testers, look, remember, you are not the customer. You are not the customer here. You have to try to constantly channel your customer as you're running your tests. I told them, try to think of somebody in your family who's just totally non-computer literate, has no idea what you do and what it's about and so forth. Try to think, would Uncle Joe like this? Would, Aunt Serena like this? Because it is important if you're doing any kind of testing, but especially exploratory testing, that you be able to see the product from the customer's eyes. Otherwise, you're not doing any validation. Now, that's not to say that verification doesn't have value. So verification, remember, is about checking against defined requirements or a defined design specification or some other written description of how the system is supposed to behave. Now, in verification, it's less important that you try to channel your customer or end user because your primary oracle is the specification document, or possibly a reference system or some other predefined thing that you're going to say, okay, I'm going to measure against this, and as long as it behaves this way, I'm going to call the test a pass. Now, hopefully the difference between validation and verification is clear from what I just said. If not, I'm going to be running a webinar on this in 4 months, 3 months, 4 months, sometime in the future. And I will get more into the differences between those two things and why they're both critical components of a well-balanced testing program. So with this said, all this said, and then my definition of exploratory testing and what it is about, oracles and bases and verification, validation out there. Let's look at some of these myths that I wanted to address, and then we'll come back to how you can make exploratory testing work for you a little bit later. So the first myth that I want to bust here is the origin myth. This is the myth that exploratory testing was invented in the 1990s in Silicon Valley. It's kind of similar to the myth that planning poker was invented by people in the Scrum community. So, newsflash, planning poker is actually just a form of the Delphic Oracle estimation technique, which was invented during World War II. Okay, so for those of you who believe that the Scrum gods from on high handed down planning poker, it's actually just a well-established project management best practice that has been around, longer than your grandparents probably, and is a great idea. It's a known best practice. It just got repackaged with a new name. The same kind of thing has happened with exploratory testing. I mean, think about it. The first person to write a program and to run it had to spend some amount of time testing it. So how did they do that? That nobody had spent any real time thinking about how you would go about testing things. Now, if you were doing a program that did some mathematical calculations of some sort or another, then of course what you would do is you would do hand calculation of, I don't know, the differential equation you were trying to solve or whatever. But here again, what's your test basis and your test oracle? Well, it's your knowledge and understanding of how to do the mathematical equation that the software itself is trying to solve. It's exploratory testing. How are the values getting picked? Unless somebody had some sort of flashing insight into the value of boundary value analysis or something like that, they were probably just going, okay, well, what would be some interesting values to pick? So it's almost certain that exploratory testing has been around as long as software and has always been in use. Now, we can definitely say that it was widely used at IBM starting in the 1960s. Now, how can I be so sure of that? Well, Fred Brooks, in his book, The Mythical Man Month, describes independent test teams as part of IBM's approach to testing. And Glenford Myers, when he wrote the book, The Art of Software Testing, which described how testing is done at IBM during that time period, that was published in the 1970s, mid-70s. Mythical Man Month was published in the early 70s, but it was based on his Brooks' experience managing software development in the 1960s. So we can bet that exploratory testing has been practiced as a recognized test technique at least since the 1960s, and done not as so much as a recognized test technique, it's just as a matter of necessity prior to that. Now, the thing is, the thing that can be a little confusing about this is that when Myers described this in The Art of Software Testing, he didn't use the phrase exploratory testing. He called it error guessing, because what he was describing was using your knowledge as an experience as a programmer, familiar with the kind of mistakes that you yourself make as a programmer, thinking about the kinds of failures that occur because of the bugs created by those mistakes, do those kinds of tests. So it certainly can be described as a somewhat focused or constrained, if you will, approach to exploratory testing. I think if you go back and read Glenford Myers' description of it, you'll say, oh, yeah, that actually is exploratory testing by a different name. So, one myth busted. Now, the other myth that comes up with exploratory testing is the completeness myth. And this is one that you run into in certain organizations that want to have a very immature approach to testing and often a fairly low commitment to quality. Is just just have some people, maybe even the programmers who wrote the code themselves, sit down and play around with the software, make sure that everything works fine, and then we ship it. Um, that's closely related to the common non-tester perception of testing, which is just like, how hard could it be? Just make sure it works before you ship the software. So you will run into this. There is quite a bit of it out there. Now, in any given organization, the myth is self-dispelling. After a while, the incompleteness of this technique will reveal itself, and hopefully not. Well, hopefully, I mean, maybe we don't care. It depends on what the organization produces. But for the sake of the people who are employed by that organization, they can hope that this myth is dispelled in a relatively gentle fashion that allows them to discover better ways of going about testing than just sitting around and beating on it a little bit before you ship it. Now, the thing about that, you might say, well, if the myth is self-dispelling, then how dangerous can this myth be? Well, quite actually, because it's kind of, to use a rough and maybe somewhat ghoulish analogy here, it's kind of like, it always amazes me, I hear about people and how popular in the United States anyway heroin is now. It's always just like takes me totally aback, because I'm like, God, I mean, even when I was in college, and I went to college in the 1980s, and if you know what, in Los Angeles, so if you have any idea what the culture was in Los Angeles in the 1980s, you can imagine it was a pretty wild and woolly place, where a whole lot of stuff got done by a whole lot of people. But even in that environment, there was this perception of, oh, no, heroin, that's bad medicine, bad juju, don't touch that stuff. But then I have to remind myself, well, wait a minute, this is a whole new generation, right? And that they hadn't, the people who are getting hooked on heroin now were not people who grew up in sort of the shadows of the 70s and had seen the kind of wreckage that heroin had caused in the 70s and was still continuing to cause to some extent in the early 80s. So this is kind of one of these things about human beings, is that individuals learn, but societies learn a whole lot more slowly, and sometimes have to relearn things a number of times. And it's the same way within a given profession, that this sort of just beat on the software a little bit and make sure it works before we ship it, and yeah, that idea will go away within a given organization, but it will keep popping back up, in part because we have very weak testing education in your computer science curricula at universities and colleges. So people are still graduating with computer science degrees that, from a testing point of view, are not too much different than what I had when I got my computer science degree in the 1980s in UCLA. In my software engineering class, we spent 1 week talking about testing. So that was the class met 3 times a day. So that's 3 hours of discussion about testing. Most of that was about unit testing and integration testing. And on the end of the last session, there was this discussion of, oh yeah, right, there's this thing called system testing. It's done by these kind of weird guys called testers. And they use some techniques like boundary value analysis and equivalence partitioning and so forth. And maybe someday you'll meet one of these obscure individuals. So now I shouldn't be too dismissive. It is getting better, and there are certainly some more shining examples of where a more enlightened approach to teaching software engineering, where there are classes on testing and so forth. But it's certainly not the case yet that in order to get a computer science degree, you have to take the equivalent of something that would cover the body of knowledge that's in the ISTQB Foundation syllabus, which I would say that by itself is necessary but not sufficient to be a full-fledged professional tester. So we haven't even gotten to that point of view. And so let's say that we could get to that point where you had people taking a class that because that if you flesh it out, that's basically like a one semester class of that syllabus. You could build a one semester class from it, and I know professors who have. So let's say we had that, and we had the next step up of somebody doing the advanced test analyst, which is a more in-depth version of the black box test design technique. So 2 classes that you had to take to get your computer science degree. And you can say, well, then would that be enough to dispel this myth finally? Well, no, because you still have the problem that people get jobs in IT that don't have computer science degrees or any relevant degree. So this myth would keep coming back via that channel as well. But that's, of course, a whole separate discussion about setting standards for what it means to be qualified to be a IT professional. Okay, so the completeness myth that I just talked about is really based primarily on ignorance, I guess you could say, on a lack of awareness, if you consider ignorance to be too strong of a word. The sufficiency myth is based on a different problem, which is arrogance is too strong of a word, but hubris might be the right word to use here. That this idea of, look, I've been trained by some mighty Jedi or another of exploratory testing, and therefore I am able to find every bug that matters. I can be confident in my testing work, and even if I only have an hour to test the software. Okay, go look at some studies that were done at Microsoft. You should be able to dig these up on the internet easily enough. I believe the guy that I got this information from was B.J. Rowlandson, who I think is still at Microsoft. At least he was at the time. He gave a presentation at a conference in, I think it was Frankfurt, that I was at and he was at, and basically what he was citing some studies done by some folks at Microsoft, and this is industrial experience here we're talking about. We're not talking about studies done in a sort of a toy academic environment like you sometimes read these papers that have been done by researchers at a university in computer science, and they're working in an environment that's definitely non-industrial. They're not talking about developing applications for sale. And we're talking about Microsoft here, right? And I certainly am well on the record as having my differences with Microsoft and their approaches to testing and quality, but they're still, by any stretch of the imagination, a legitimate case study in full-scale mass market and data center software development. So what they found was that the set of bugs that are found by exploratory testing and other kinds of reactive test strategies, such as the other experience-based techniques that I described, is different than the bugs that are found by other test strategies. And the 2 different sets are overlapping, but only partially so. So even if you did a perfect job of doing exploratory testing and applying other reactive test techniques, and you found every single bug that you could possibly find using those techniques, you would still miss a substantial proportion of the bugs. So it's not sufficient by itself, and it cannot be. And similarly, the other techniques, black box test design techniques, applied in some sort of analytical testing strategy like requirements-based or risk-based testing, those also are insufficient by themselves. White box test design techniques applied as part of TDD, for example, are insufficient by themselves. This sufficiency myth is not unique by any means to exploratory testing. It is the sufficiency myth is promulgated for TDD. I've run into that. And it's sometimes promulgated for analytical requirements-based testing. I mean, I think if you take a look at some of what was written in the 80s and 90s about testing, that analytical requirements-based testing was held up as this gold standard, and that was the way you did it. So what I like to say to people is think of testing as a water purification system. Think of it like a water purification system. In a water purification system, they don't just have one filter. They've got multiple stages of filtration, each designed to filter out different kinds of impurities and contaminants, sticks and dirt and bugs and those kind of things are all filtered out at different points. So similarly, if we use different strategies and different techniques, each of which covers a different set of bugs, non-overlapping sets of bugs, together we will create a very powerful bug filter. But without that, no single strategy by itself is going to be anywhere near 100% defect detection effectiveness. But even with it, it's important to remember that application of a wise mixture of many different testing strategies still won't get you to 100%, but it can get you close. I do have clients that regularly score in the 99 to 99.5% defect detection effectiveness. So sometimes the sufficiency myth is on the other foot, and you get the irrelevance myth. Exploratory testing is irrelevant because we have TDD and we have ATDD and we have BDD, test-driven development, acceptance test-driven development, and behavior-driven development. And so we should have 100% confidence in our software. And this is a myth that that you will run into by some in the Agile community, either explicitly or implicitly. But notice that test-driven development, acceptance test-driven development, and behavior-driven development are forms of verification. So in test-driven development, the tests are effectively an executable requirement specification. That's what your JUnit tests or PHP unit tests or whatever those are. Those are basically a requirement specification that says in code, this is how the software ought to behave. So when you run those tests, you're just verifying that, yep, the software behaves that way. Acceptance test-driven development and behavior-driven development, your tests and your expected results are going to be created based on an analysis of a user story and its acceptance criteria. So again, we're just verifying. And code is never perfect, and requirement specifications are never perfect, and design specifications are never perfect. No human work is perfect. We don't do perfect. That's not what human beings are good at. We're not good at perfect. We're good at a lot of things, but perfect ain't one of them. And so any total reliance on verification is going to mean that there's a whole bunch of bugs that you're just not going to find. So if you're in an Agile project, then what you want to do is you want to apply the 4 test quadrants. And you speak test quadrant language because that's what people will understand. It's a balanced mix of verification and validation of tests that are both business-oriented and technology-oriented. I'm assuming if you are in an Agile world, you're probably familiar with the test quadrants. If you're not, then I'd say read up on them. If you are in a non-Agile type of environment and you're like hearing those test quadrants, what is he talking about? Don't worry about it. Just think about the different test types and the different test levels that are discussed in the ISTQB Foundation syllabus, because that's basically the same. It's the same ideas expressed differently and drawn differently. But certainly any complete approach to testing would need to include experience-based testing, and any complete approach to experience-based testing would need to include exploratory testing. Now, another thing that you sometimes run into with exploratory testing is the unmanageable myth. And I will admit that there was a time back in the late 90s when I had a very jaundiced perspective on pure exploratory testing based on this same thing, the unmanageable myth. In fact, in the first edition of Managing the Testing Process, I compared exploratory testing to a local tradition down here in South Texas, which is to have this thing called a piñata. And I assume that probably all of the American listeners are familiar with a piñata, but since a number of you are from out of the country, I'll just explain briefly what it is. A piñata is a paper mache figure, usually an animal of some sort or another, that is filled with candy, and it's hung up by a string from a tree or something like that. And children are blindfolded and given a baseball bat or other stick, a hard, thick stick, and they just beat on this thing or try to beat on it until it breaks open and all the candy falls out. And so I compared pure exploratory testing to basically, beating on the software like a piñata and hoping that you broke it open and the bugs came out. What I was advocating in that book was, to the extent that you were going to do exploration, that you would give testers latitude to deviate from pre-written test scripts and would go off and do some exploration prescribed within the bounds of the pre-designed written test. Because my belief then was, if you allowed someone to do purely exploratory testing, you're going to have no way to manage it, and you're going to have no way to capture test coverage. And I think in the late 1990s, when I made that statement, it was kind of sort of true that a lot of the exploratory testing that went on, and certainly a lot that I saw as a test manager, did fall into that category. People kind of going off. I saw this many times, that people would go off, come back and go, oh, I found all these great bugs, and they would enter all these bug reports, and I'm like, well, how did you know to look there? I don't know. Well, how did you get there? What else did you test? What worked? I don't know. In the time since then, this has really truly become a myth that it is possible to manage this. So there are logging tools that are out there. For example, is something called Rapid Reporter, or Rapid Reporting. I can't remember which of the two, but anyway, it's an open source tool. There are commercial tools you can get as well, which will allow you to capture what you covered. So not just what didn't work, which is going to be in the bug report, but what did work. You can take notes. Hey, I saw this sign of potential instability. Here's some things I think we should do next. Here's some details that we ought to pass on to this particular person or that particular person who might be interested. Here's some questions that I still have about how the system behaved or the resources it required, so forth, the kind of data we should test with. And you can even capture what the actual behavior was with video clips and screen captures and so forth. And this can all be put within a nice, well-contained box via the use of what's called a test charter, which assigns the particular conditions that are required to be covered during that time box, where anywhere from 30 minutes to 2 hours, where people are going to be doing exploratory testing. So I think that this is now a myth. Unmanageable exploratory testing is now a myth, but I think in the 90s it probably was more true than not. Okay, so with the myths busted, let me talk a little bit in the time that remains about some ideas about how to apply exploratory testing in a way that avoids all those myths and takes advantage of its strengths and minimizes your exposure to the weaknesses. So as I've said before, you're never going to get perfect requirements. So you need to do validation. You're always going to have the situation where exploratory testing will be able to reveal a certain set of bugs that you wouldn't find any other way. So definitely, exploratory testing and other kinds of reactive test techniques are important anytime. Certainly if you're in an agile world, which increasingly people are. That same survey I referred to earlier showed that a majority of projects now incorporate at least some elements of agile into them. Since those projects tend to have limited documentation as well as lots of changes, relying on testing strategies or incorporating testing strategies that do not rely on a lot of created documentation of such as test cases makes sense. So you want to have a good blended approach, reactive testing together with other different strategies. Now, if you're like going, he keeps using this word test, this phrase test strategies, what does he mean by that? I did a webinar on testing strategies, and it's recorded. You can go out and give it a listen, and it talks about the different strategies and what they are, what kind of techniques are used in them. Now, in the case of exploratory testing, what you would want to do, as I said before, is do some analysis to figure out what conditions you want to cover prior to the exploratory testing sessions, and capture those conditions in the appropriate test charters, and then give an estimate of how long you think it would take to do that. Now, when I say test condition, I mean what we want to test, not how we want to test it. So, for example, if you're testing an e-commerce application, one of your test conditions might be test making purchases with a supported credit card. Right? Notice that doesn't say anything about how you're going to test it. You know, what goes into the shopping cart, for example, what the purchase total is. But we know, that's one of the things that we want to test. So in your test charter, so what's handed to the tester at the beginning of the exploratory testing session is this test charter that includes this test condition and possibly other ones, saying, okay, well, one of the things I want to test here is, can I make purchases with a supported credit card? And maybe I give somebody 45 minutes to do that. Go off and spend 45 minutes trying to make different kinds of purchases with supported credit cards. Make sure that that works. And then the tester designs and runs tests to actually test that condition once the software is delivered. Now, you as a tester can use formalized test design techniques, black box test design techniques, white box test design techniques, defect-based test design techniques as part of how you come up with the specific tests you run. There's nothing that says you can't do that, and in fact, you should. The important thing, if the test is to be truly exploratory, is that you're not committed in advance to any particular set of steps. You are going to let the software do what it's going to do in front of you, and as you're testing this condition, and based on what it's doing, you're going to say, well, I should maybe try this or maybe try that. Now, these testing sessions, let's say I'm managing a test team. I got 3 testers. If I just said to those 3 testers, okay, here's the application, and it is an e-commerce application, say, I want you guys to go off and figure out, how well it works, and just turn them loose, they could come back at the end of the week and say, well, man, it kind of looks okay to me. Well, how do I know they didn't all go off and test the same thing for 5 days, right? I don't know that. How do I know what they tested? I don't know that. Now, the logging that we were talking about before can help you with the how do I know what they tested, but how do I prevent them from having a bunch of redundant work? How do I make sure that everything that needs to get tested gets tested? Well, by defining those test conditions and breaking them up into different charters, and then assigning those charters to people and assigning a predefined amount of time to each charter, I can make sure that I know where I'm going to emphasize in my testing, that I'm not doing a lot of overlapping from one person to another, and that I'll be able to say this is what I tested at the end of that period. So this is how these exploratory testing sessions can be managed, and this is just again back to dispelling that myth of the unmanageable exploratory test. Now you want to make sure that the sessions allow people to go broad across the whole product. The session should also allow for someone to go deep into a particular feature or function and really get to evaluate that thing, and possibly even very deep kinds of coverage like testing combinations and workflows that flow through multiple parts of the product. And this, of course, has to be, you have to think about it from a risk point of view. You start getting into combinatorial testing where you're testing a lot of interactions between different parts of a product. Well, when you think about Microsoft Word or something like that, that can be a pretty um, hectic kind of set of combinations. They're pretty enormous set of combinations. So you want to be careful with how much deep coverage you're going to try to do. Now, in terms of how the charters are documented, I'm going to give you an example of that here shortly, but some things that you might put in your charters is, who's the intended user here? Again, helping the tester channel the intended user and their perception of what quality is. The test conditions you want to cover, of course. Any sort of preconditions that should be met, like is there data that needs to be loaded before we try to do this, or is there some other feature that needs to be working? Prioritization. Certainly you want to use an awareness of risk to order the charters, and so that if you run out of time, any sort of exploratory testing charters that you didn't get to are less important than the ones you did. Your test basis and test oracles, to the extent that there are test basis and test oracle sources that someone should be aware of and refer to, that should be something that should be listed. Excuse me, easy for me to say. The kind of data that would be loaded, as I said, you might give some activities, things to try, though you have to be careful here because the more you put into these test charters in advance with respect to activities, the less exploratory they are. So, if there's certain stuff that you think is really important not to miss, then list it, but beware of converting this from an exploratory test to just basically a checklist type of test. Now, for the individual tester, it is easy enough to get lost in the weeds while doing this. So there's some good questions to keep in mind and heuristics to use while doing the exploratory testing. So, do not be distracted by the bright, shiny object. Again, what's important here? Of course, as a tester, and anytime a tester is doing any kind of test, including exploratory testing, you should be thinking about what could go wrong. You want to have that professional pessimist attitude. Again, look at the product from the customer or user's point of view. Is this what they want? Will they be satisfied with this? Will they like it? What ifing, trying different things, that this can be valuable, but again, you have to be careful not to go off into the no real user is ever going to do that scenarios, because that could end up being a waste of your time and everybody else's. And also you want to think about installations, upgrades, and uninstalls. Now, personally, I think that these are probably important enough to have their own set of test charters. In fact, this is one of the great under-tested areas of software. I think in a couple months I'm doing a webinar called the Scourge of the Under-Tested Automatic Software Update, where I'm going to talk about stuff that goes wrong when upgrades are released for software and they aren't adequately tested. So this is really something that you need to look at. Again, use any source of ideas that you have, any knowledge, experience, creativity, skills, anything that's relevant, use it. If you're a manager, encourage people to use those things. And then heuristics, looking at boundaries, both functional and non-functional boundaries. If you're dealing with databases, remember CRUD, create, read, update, and delete. Configuration variations, what are the different ways that the software can be set up? And interruptions, especially with mobile applications where interruptions are just a constant ongoing thing, and happening in an environment with very limited resources. Thinking about what if this happens while I'm doing this, is always a good thing, and particularly in mobile, but really in any kind of environment. What happens if the network starts to go really, really slowly while I'm in the middle of trying to transmit a large amount of data to a server? So I noticed that somebody had asked a question about, can you give me an example of a charter? So yes, I can actually. Here's an example. This is derived from real life. Once upon a time, as a test manager, I was managing a test team, and we were testing a kind of, I guess you could think of it as an early version of a netbook or something like that. It was a very stripped down computer that allowed you to surf the web and send and receive email, referred to at that time as an internet appliance. And it was supposed to be configurable for kids and teens as well as adults and seniors. And for the kids and teens devices, we had to have filtering. And so we used exploratory testing to test the filtering. And in fact, I organized I guess you could call it a bake-off. What had happened was we were finding bugs in the filtering, and we were reporting bugs against the filtering, and the bug reports would say things like, filtering software allows access to hate speech websites. So filtering software allows access to pornographic websites. And we get this kind of yeah response. Okay, it's a bug. We'll report it to our filtering vendor, and we'll have them work on their filtering software. It still kept being a problem. Every time we got a new release, we test that. We it's still broke. It doesn't work. So I did this, like I said, this kind of a bake-off thing. I got all of my testers together one morning, and I told them, if the words hostile work environment have ever occurred to you, or if you're easily offended, you have the rest of the day off paid on me. Just go away. You'll be glad later if you're not here today. Now, at this point, all of my testers were intrigued, and so none of them got up to leave. And I said, okay, so for the rest of you, what we are going to do is some focused exploratory testing. Each of you is to get your device configured as either a kid's or teen's device, and you are to get a top 10 list of nastiest websites you can get to. No fair having overlap. Everybody has to have their own. You guys work out amongst yourselves how you're going to break this up so you're looking in different places. And then after lunch, we're going to have a show and tell of your top 10. And so I went downstairs and talked to the marketing folks, who were the ones who were kind of poo-pooing our bug reports, and said, hey, kind of around 1:30 or 2 o'clock, can I have you guys come upstairs? I'm like, yeah, 2 o'clock is good. And what do we want us for? Oh, we just want to demonstrate some problems that we think you should be aware of. And so after lunch, we had them come upstairs, and we gave them a little demo, a little show and tell. And they left having seen, I think we had 10 testers, so it's top 10, so there's 100 truly nasty websites. They left, and they looked a lot different than they looked when they came in, because when they came in, they had that kind of post-lunch, kind of chilled out, big grin, digesting barbecue look, and when they left, they didn't look that way at all. But by magic, the filtering software got a whole lot better. I could not have done that without exploratory testing. There's no way that I could have written a set of scripts that would have led to the discovery of that kind of those kinds of problems. This is something that the human brain does very, very well, is respond to evolving circumstances and learn. This kind of thing that you're seeing here, while we weren't anywhere near as formalized, was the perfect type of test to run against that kind of software. So learn to recognize situations where software is a perfect fit for exploratory testing. Whether you choose to put this much detail and documentation around your test charters, or if you want to keep them a little more lightweight, is of course up to you. But I think you get the basic idea here of having these charters and having a smart way of breaking up the work will make this a manageable and productive part of your testing process. So to wrap this up before I open it up to Q&A, I see we've got a lot of questions submitted already. As I said, exploratory testing, if we have to talk about somebody inventing it, it was almost certainly invented by the first programmer when he or she sat down to test the first program. We've explored a number of different myths around exploratory testing, some which extol its virtues beyond its true capacity, and some which put it down in ways that aren't fair. By knowing those as myths and recognizing how to avoid them and limit their damage, we can really be more effective and smart in the way that we use this proven best practice of exploratory testing. As I've pointed out multiple times, exploratory testing is an essential element of any good testing process, but it is only one element. It cannot be relied upon entirely, is not sufficient by itself. No technique is sufficient by itself. To avoid the unmanageable exploratory testing problem, we've looked at techniques like time boxes and charters and logging tools to keep it productive and measurable. So by putting those in place, you will be able to, in an effective, efficient manner, take advantage of the skills and experiences that you have, or if you're a test manager, the experiences and skills that your testers have, to find some bugs that other techniques would miss, such as the example of the filtering bugs. Okay, so let me put the advertisement up. I'll open it up to questions here. I got a question from longtime listener Craig. Good to see you there. Who says, question or another myth: when is the best time to do exploratory testing? Well, I think what you mean, Craig, is should I do this at the beginning, the middle, or the end, or throughout the test execution process? So I think the answer to that would be throughout. And that's certainly how I have done it as a manager, is to have it sprinkled throughout the testing process. And also, another thing I would say is make sure that people can do some like kind of mini explorations, that even when they're running a pre-designed written test, that they have permission to go beyond that test. As I mentioned before, something that I've said often to testers is, think of a written test case as a roadmap to get you to interesting places. And if you get someplace interesting, stop and look around. So, tell people, look, exploratory testing is like not just something that has to be off in its own box. It can be incorporated in a small way, even into your pre-designed tests. Now, another thing that you might have meant by your question, Craig, is time of day. This gets to, when people are feeling productive and creative. So I don't know that you could prescribe this uniformly, but I think you want to encourage people to do exploratory testing at times when they're more likely to be feeling creative, and to do it for periods of time that are limited too. There's some research out there, cognitive psychology kind of stuff, that basically shows that you can go for about 90 minutes and then you're going to get kind of fried. So, you don't want somebody sitting down and trying to just do a bunch of exploratory testing for all day long, because they're not likely to be able to keep up that pace of creativity for an entire day. Let's see. Amit has a question here. As for your definition of exploratory testing, I've heard the term not scripted testing. Is this similar to your definition of ET? Not scripted. Well, I mean, I guess not scripted is kind of like what I meant by nonlinear. So I think that would be part of it, but I don't think that by itself is enough. To just say it's not scripted would not be enough to say it's exploratory testing, because I could just be doing purely ad hoc testing, sitting there and just beating on the system to see what happens without any sort of organizing principles or structure or anything, and that's not scripted either. And I wouldn't call that exploratory testing. Also, I've seen a lot of users do testing where they're doing like a user acceptance test, and they're just doing what they do in their day-to-day job. That's not scripted.
Okay, so
I wouldn't say that that's exploratory. So I wouldn't use the term not scripted testing as a definition.
I don't know what's happened, but I
think exploratory testing is definitely not scripted testing.
I should,
not all
and
not scripted testing is exploratory testing.
I'm just don't think about it when it happens. Man,
let's see. We've got a question from Luciano.
Well,
in a structured testing
somehow
environment,
people are getting to me.
That is using test plans, test scenarios, and conditions. How do you make it an artifact to show exploratory testing?
Yeah.
What types of layout
so maybe I don't really
use to make it traceable, and do you have examples of charters? Okay, I think I answered some of that with terms of the rapid reporting thing that I mentioned, the logging tools and charters. Though you do bring up the issue of traceability, and I think this is important. Certainly, when you are capturing your charters in whatever test management tool you use, you need to
I've got this
establish traceability
the Agile
between
Tester
those
one that I don't
and what they are covering in the product.
Between the CTFL and
now
the
that might sound
CTALTM,
like I'm totally contradicting myself, because you might say, well, wait a minute, if there's traceability, isn't this just verification? Well, notice I didn't say traceability to the requirements, though there could be a relation between something in testing and the requirements. But there should also be traceability to other things. One of the mistakes I think that people make when they use a lot of these test management tools is that they get trapped by the assumption that's sometimes built into the tool, which is, I've got this tab, like if you think of Quality Center, or whatever we're calling it now, ALM. I've got this tab that says requirements, and I have my test traceable back to requirements. So therefore, the only thing I'm tracing is
still important. So I don't know if you can squeeze them on.
Excuse me. Well, no.
Oh, you do.
It's really, that tab shouldn't be called requirements. It ought to be called test basis. And that could trace to any number of things. They could be requirements, they could be risks, they could be supported configurations.
Well, I shouldn't have my
webinar a while back, which is recorded.
The only thing I have is my phone
called Dimensions of Test Coverage.
If you put the
so when I'm talking about traceability here, I'm talking about traceability back to the different things that you're trying to cover. So you would establish traceability between the charters and your test basis elements, and also when you go and you do your rapid reporter, or however you're going to capture what you actually tested, that would need to go in to the test.
You know what? You have a better idea. Use the ICTV.
Traceable to the charter that it was associated with.
All right. Oh, that's helpful. Thank you.
That level of information, and in that way. Your exploratory testing, Luciano, is every bit as documented and as auditable and relatable to the test basis as everything else that you're doing. It's just that some of that information happens to be captured during test execution. All right, a question here from Chris. Let's see. Chris asks, what are some other tools that can help track the coverage of the exploratory testing, recording what the tester actually did in the system? Well, I just described how you would incorporate, incorporate maybe is the wrong word, how you would capture information about exploratory testing in a tool like, say, ALM or Rational Test Manager, or as I said, Microsoft TFS, I guess it is, the Microsoft tool. Or Virtual Studio Foundation Server, I guess it is VSFS, whatever alphabet soup is the Microsoft tool. I just described how that would work. Now, you specifically mentioned recording what the tester actually did in the system. There are tools like Snagit that can be used to get screen captures, and there are video capture tools, and any web search will reveal a lot of different possibilities here. There often are open source free tools available. So before you spend a whole bunch of money, I would encourage you to look at the free ones. So for example, at one time in Quality Center, and they might still have this, there was a recording tool that would allow you to record things that were being done by the tester, and it was basically a stripped down version of their capture playback tool, and to me that just seemed like killing an ant with an elephant gun, of setting up a capture playback tool and then capturing what was being done. And the rationale for it was, well, you just record everything that's going on, and when you file a bug report, then the developer can play it back. And I'm like, really? A developer's going to sit there and watch a 90-minute long or 60-minute long exploratory testing session? That doesn't sound like any developer I know. Hang on. I just got some reports of some audio problems. Okay. Hopefully that has solved it here. This is the weirdest thing. God, this is yet another interesting Citrix bug. It has me in here twice, as the organizer and then as the organizer and the presenter. I have no idea how that happened. That is bizarre. Anyway, hopefully that problem, the audio problem, is gone now. Someone else is speaking. Yes, looks weird. Okay, yeah, apparently some of you heard that and some of you, I guess, didn't. No. Getting crosstalk from somebody talking about ISTQB. Getting the voice of someone. Getting the voice of someone besides Rex Black coming in and out talking over Rex. Rex, I think someone else is being picked up by your microphone. Huh. Yeah, Scott says, sounds like crossover at GoToWebinar. Wow. 2 conversations during Q&A. It's making it 2 Rex Blacks talking. Line is very clear. I hear a lady talking loudly along with you. He's gone now. Seems to have stopped now, but it occurred on and off throughout the webinar. It stopped. Okay. Okay. Well, some of you described this as sounding like another person. If you've got any ideas, a person and a dog. Wow, that is bizarre. Apologies to those of you who were affected by that. If you were affected by that, and you could email us a description of what it was that you were hearing. I'm of course going to go back and listen to the recording and see if maybe we captured that on the recording. Given the nature of this webinar and some of the people whose ox might have been gored by this, I wouldn't completely discount somebody trying to hack into this. Though it could just be that there was a bug. Could just be that there was a bug on the in Citrix. I will listen to the recording and see what that was, and I see people saying definitely another person. I guess they did not do any testing of their solutions themselves. Yeah. Sounded like a phone call, one-sided conversation, and occasionally dogs. Thought I heard a dog bark. Lady laughing, multiple people talking. That's weird. Okay, Julie. Well, thanks for that. Looks like it was a lot of people. Yeah, if you could just send me email me a brief description of when it started and what was going on, I will try to run this down with Citrix. It looks like they kind of maybe didn't test their software well enough. um, okay, let's see. Some other questions here. You mentioned, Amit says, you mentioned that exploratory testing was not invented in 1990, but rather that it was probably done by the first person to program. Yes. I mean, I think that that's almost certainly the case. Meet says, since inventing an activity is usually the act of giving it a name, do you happen to know of any name that was given to such an activity? Yeah, I mean, it was error guessing is the name that was given to it by Glenford Myers. I think that before that, people just probably called it testing because they didn't think about it in any particular way. It was just part of what they did. Let's see. I got a question from a B. Willingham. How can test effectiveness be measured with an example of greater than 90% if you can never test everything? Well, okay. So when I was referring to effectiveness there, I was referring to defect detection effectiveness. So defect detection effectiveness, the way that you could measure that is this. Let's suppose that you've got an application, and you test this application and you find 90 bugs, and you release it, and your customers in production subsequently report 10 additional bugs. So you found 90% of the bugs. So your defect detection effectiveness was 90%, right? Because 90 divided by 90 plus 10 is 90%. Now let's suppose that you found that of the 90 bugs you found, 19 were important bugs, and of the 10 bugs found by your customers, only one was an important bug. So now you've got 19 divided by 19 plus 1, or 95% defect detection effectiveness against the important bugs. So I can measure my defect detection effectiveness against all bugs and my defect detection effectiveness against important bugs, and I would want to be more effective at finding the important defects than all defects. Now, in terms of test effectiveness, I think what you're talking about there is coverage, and you can say, yeah, well, true, you can never test everything. So that is absolutely a true statement. The number of tests is either infinite or so close to infinite that you can't possibly hope to get there. But you can define your different dimensions of coverage, and you can define the appropriate depth to which to test. And so, I don't think it's a hopeless case. It's just a matter of separating out what you should test from what you could test. What you could test is infinite, but what you should test is finite. And the depth to which you test it can be determined as well. So I'd encourage you to look into things like risk-based testing and see what ideas hop out at you there in terms of how to distinguish what you could test from what you should test. Let's see. Connor asks, will this slide deck be available afterwards? Well, not only the slide deck, but also the recorded webinar. Sounds like there might be some issues with the recording, so it might not be this session that's available. I might have to record the evening session and post that one because this one, it might turn out as this recording might be too problematic with respect to the crosstalk. The slide deck is already available. If you go out to the RBCS website, rbcs-us.com, go to the resources tab in the upper middle, and then go to the basic library. You'll be able to find it there. So that is already out there. Let's see. Craig asked, crosstalk seems better at the moment. Given that exploratory testing is an experience-based technique, when you are assigning exploratory test sessions, do you prefer only to use people with very good knowledge of the system, or do you also assign test sessions to less experienced testers as well? Excuse me, I needed a drink of water there. I would say generally, I mean, if we're talking about taking advantage of people's skills, experience, and knowledge, I mean, I think you want to assign experienced people to do the exploratory testing. They're going to be better able to figure out what it is they need to do. Excuse me. Now, in terms of the use of less experienced people, certainly in usability testing, finding somebody who's got a lack of experience similar to the lack of experience that will be true of some of the user base, that is something that you can do, but you usually want to put some structure on that, and there's some approaches to usability testing that we don't really have time to get into that allow you, but they do allow you to put some structure about structure around how you use that person as a tester. I think you want to do that, but that's really as a form of usability testing, and not so much exploratory test of the functionality of the system. Debbie says, what should be the expected percentage-wise in terms of the defect detection effectiveness, that is. What should be expected percentage-wise if we are truly effective? Our stakeholders expect perfection. Yes. Okay, so the last point first. People need to understand that no test organization is able to detect 100% of the defects. None. So that's if you have stakeholders who are coming back and beating you up, like, oh, how come you didn't find all the bugs? Why did you guys miss that? You need to explain to them that because of the infinite number of tests that are possible, there's no way to test everything, and therefore there's no way to find all the bugs or reduce the risk of failure in production to zero. You can't do that. It's just simply not a possibility. So you want to dispel that particular myth, because that's a very common myth about testing held by non-testers, that the testers can find everything. So you gotta dispel that first, and then have the conversation about here's the percentage we can find. And this is why I recommend to people that they sit down with their stakeholders and come up with a clear statement of what it is that they're supposed to accomplish. What are our objectives? So the typical objectives would be finding bugs, building confidence, reducing risk to an acceptable level, providing information, and you can define those objectives and then define goals for those in terms of effectiveness and efficiency, like with the defect detection effectiveness. At some point, if I haven't already, I will do a webinar on that exact topic. I believe I have talked about that, though, with respect to defining objectives and metrics for them and so forth. It's very important, because otherwise you can't just go, well, we can't find all the defects, so that's not a realistic expectation, because that leaves open the question of, well, you can't do what I thought I was paying you to do, so why am I paying you to do anything? So you need to be able to say, Well, I can't do that for you, but certainly finding defects is an important part of what we do. Let's talk about what percentage we should actually find. Okay, Luciano has a question here. He says, if you were to try and gauge effectiveness of a type of testing used on a project, such as how well it did automation, manual, or exploratory types of testing, would applying the effectiveness of how many defects were introduced in production be a good measure over time to evaluate and gauge each type? No, no. So, certain, if we say testing as a whole has as one of its key objectives finding defects, I think that's an accurate statement. The problem is that there are some particular types of testing that are actually not about finding defects, or at least not very much about finding defects. So, for example, regression testing is more about confidence building than it is about finding defects. And a lot of automated testing is regression testing. And this is a mistake that organizations make, is that they do a lot of test automation, and then they measure the defect detection effectiveness of their automated tests, and they go, oh, well, we're not getting a lot of value out of them because they're not finding a lot of bugs. Well, hello. Remember the pesticide paradox. And the pesticide paradox is a term that was coined by Boris Beiser in his book Software Testing Techniques, and it was written in the 1980s, but is referring to something that had been known for a long time, which is basically if you run the same set of tests over and over again, eventually those tests stop finding new bugs. And that's what regression tests are. So you really, in terms of your regression tests, you want to measure the value of those. You need to look at the savings in time as typically what people are going to look at. Of how long would it take me to get to the same level of confidence from a regression point of view if I had to do this testing manually. Let's see. Connor says, since various products have different contexts, couldn't product A have a 90% defect detection effectiveness rate, but be higher quality than product B that has a 99% defect detection effectiveness rate? If so, what's the purpose of using these metrics? Okay, so the defect detection effectiveness metric is about measuring your own your test organization's effectiveness over time, benchmarking yourself against industry average, baselining yourself against your own behavior, and eventually improving to what you would consider to be an optimal level of defect detection effectiveness for your testing organization. So certainly I'm not suggesting that, you know, it's easy to do apples to apples comparisons across organizations using that metric, and that's not even what it's about. Also, of course, it's like, well, what kind of bugs? You know, escape rate that meant a lot of relatively low priority bugs are escaping is different than an escape rate that means a few bugs are escaping, but those bugs that are escaping are really nasty. And, you know, you got to think of what the product is too. Like, so if we're talking about, like, this is, you know, amazing to me, but I see these commercials for this game Candy Crush. I have no idea what it is. I mean, other than knowing that it's a game that runs on mobile devices. I don't have any time to play video games like that, so I've no, but, you know, they spend money on advertising. Those ads must not be cheap. So they probably, there is a level of quality that they need to maintain so that they don't scare off their customers. But anything other than that, you know, it's entertainment, right? So they're more concerned about things like, is the software engaging and so forth, and so they're from a testing point of view, their testers need to be more focused on those kinds of issues, right? Versus there's a famous incident in terms of updates that I became aware of researching this webinar that I'm doing in a few months, where there was a software update that was applied to the systems at the International Space Station. And these software updates, they release them every year, but apparently it takes like 2 years to get one of these things done. And when they put this one particular update up in 2013, it actually killed kind of the main brain of the International Space Station. That is a real problem, right? Because you're talking about killing, potentially, if the problem is not rectified almost immediately, killing the astronauts or forcing the astronauts to undertake an extremely risky abort of the mission and eject. And I know they have some number of the Soyuz pods up there that they can use to eject. I don't know if they've got enough to be able to get everybody out of there at once. Potentially, loss of the entire space station. So, what's the appropriate level of defect detection effectiveness for that organization? Obviously, quite different. So, I mean, I take your point, Connor, but your last question there, if so, what's the purpose of using these metrics, is not rhetorical, but rather to say, well, these metrics have no value because I can point out this one situation versus this other situation. I mean, I know I've heard that argument. That's an argument that goes back to the 1990s, but that's, to me, is akin to the argument that since human beings don't have perfect eyesight, or certainly not anywhere near as good as eagles, we should just tear our eyes out because it's not perfect. I mean, no, of course metrics are not perfect, and they have misuses and so forth, but I don't think that doesn't mean that they can't be used productively and intelligently. Connor says, gotcha. So is there a guideline / magic ratio we can target for balancing manual exploratory testing hours spent versus automation-focused hours spent in a project? Magic ratio. I don't know about magic ratio. I would say that as a general rule of thumb, I've tried to use 20%. That about 20% of the test execution effort should be exploratory, but that's that rule of thumb I've used mostly in situations where our test automation rates were relatively low. The thing that's interesting about doing a lot of test automation is that effectively the automated tests are now doing what would have been done by scripted pre-designed tests. So I think that as the extent of your test automation goes up, the relative ratio of your exploratory tests might also need to go up. So that's something to just be aware of. Okay, let's see. Stefan asks, are there specific formations or training for gaining or improving exploratory testing? Certainly there's lots of different training that's available out there. Unfortunately, I think some of it tends to be, I guess, what I would describe as somewhat messianic in its claimed capabilities. So just if you do decide to go and take some training on exploratory testing, just be careful that it doesn't turn into a brainwashing session. Let's see. Sumit says, should we record the steps followed in exploratory testing even though they didn't result in any defects? Yes, of course, because that's going to be how you're going to be able to document what you covered. So that's going to be important. Now, you have to be aware of, if you're, for example, in an agile project, there are limitations on how much documentation you're going to want to capture. So, you want to try to think about, well, what's the appropriate amount of documentation here? But the tools like that rapid recorder, for example, is something that can help with that. Let's see. Kind of fishing around here for other questions. Amit says, when managing exploratory testing, you mentioned charters as a way to direct the testing effort. It seems to me that applying this carelessly could easily deteriorate descriptive testing when providing too narrow charters. What do you consider to be an efficient scope for a charter? Not too constraining on the one hand, not too directive on the other. Yeah, I think I mentioned that as a distinct possibility, that if you put too much information in, that it does start to become a test script. So I mean, I think what you want to do is you want to have your test conditions, which is what to test, not how to test it. And if there's some really critical areas that you want to make sure don't get missed, you might put those in there. But anything that's in any way procedural, I think, does exactly what you're talking about. All right. Well, we've reached the end of our allotted time, and I do want to apologize for the crosstalk. I am going to try to dig into this and figure out what happened. It's certainly an unfortunate situation. The oddest thing here at my end is I'm showing myself as logged in twice. I went and muted one of them, and that seemed to have brought it to an end, though that just doesn't make a whole lot of sense to me because well, none of it makes a whole lot of sense to me. I will dig into it, and the mystery, once solved, will be posted out on our Facebook page, RBCS Facebook page. You want to take a look at it. But anyway, to close this session, a little bit more about the resources available through RBCS. Most of you are probably aware we run these free webinar sessions once a month, usually without technical glitches. So please check our website, rbcs-us.com. If you'd like a special webinar presentation for your company only of this webinar or on any other topic related to software testing, please contact us, info@rbcs-us.com, or go to our website. You can also sign up for our regular newsletter at rbcs-us.com. This newsletter gets you valuable discounts on consulting and training services, and a regular newsletter every other month. It has a featured article on software and testing and news about what we're up to. We are on Twitter and Facebook, as you can see here. Do remember to check your email over the next couple days. You might be the lucky winner of a free e-learning course from RBCS. You were registered for the random drawing for such a course simply by attending this free event. And I think I'll probably have a second drawing just out of the attendees of this afternoon's presentation to make up for the fact that we had some audio glitches. Do check out the digital library. We've got recordings of these webinars, podcasts, and videos. You can subscribe to our podcast via the RSS feed on our website or at iTunes. And we've got videos and recorded webinars. They're on the RBCS channel of YouTube. We offer these free resources as a service to the software testing community because at RBCS we're a not just for profit company. This concludes the webinar. Thanks to everyone for joining us today. Have a great rest of the day.